SQA National Fine Maths 2017 Paper 2 Question 1. Vectors. Find the size of V, the magnitude of a vector V. So magnitude, remember, is Pythagoras. So it's just the size of V is equal to the square root of 18 squared plus minus 14 squared plus 3 squared. That equals the square root of, calculate a job for that one. I've got 18 squared plus bracket minus 14 squared plus 3 squared. That's 529. So I do the square root of 529 in my calculator, which is 23 exactly. Now, if you wanted to do it all in one go, you could use brackets in the square root sign, but it's probably easier for you just to work out your number under the square root sign first, then square root your answer.
Okay, now question 2017 paper 2 question 2 says a necklace is valued at £1,200. It is expected to increase by 4.5% per year over the next 3 years. Calculate its expected value after this time. Give your answers to the nearest pound. Be careful, remember to round. So let's start the same way. Our multiplier, 100% plus 4.5%. That's 104.5%. Change that to a decimal by dividing by 100, and this time I won't use a calculator, is 1.045. There's our key number. Use a calculator just to be sure. So then we take the money, 1200, times the multiplier to the power of the time, which is 3. So then we definitely need a calculator. 1200 times 1.045 to the power of 3 is 1369.39935. Let's just write that whole thing down. 1369.39935, which equals to the nearest pound 1369 pounds.
SQA National Fine Maths 2017 Paper 2 Question 3 had this question. It says PQ is 250, PR is 180, and this is the angle, and it's building a fence around this. We want to build a fence alongside QR. What is the length of the fence? So we need to work out the length of QR. So once again, just checking, as long as I've got the angle in the sides, either side of the angle, I can use that to cosine rule to find the opposite side. So I'm going to label this side my A. We could even call that angle A if you want, just for the sake of it. And then that would be my side B and that would be my side C. Doesn't really matter which is which. So we write down the cosine rule from the start of the exam paper. We'll always go back and check it. B squared plus C squared minus 2BC cos A. Substituting in 250 squared plus 180 squared minus 2 times 250 times 180 times the cos of 147 degrees. Remember, we could do that in one step in a calculator. Put brackets around this, minus brackets around the whole of this, and you will be fine to go. And if you do that, or you take your time on it, you get 170,380.3. And that's A squared, remember though. So that's just got 2 marks so far, substituting and getting A squared. So now just calculate our A. The square root of 170,380.3, and you get an answer of 412.77 meters. SQA National Fine Maths 2017 Paper 2 Question 4 in the quadratic formula. So now we've got a quadratic formula question, but how do we know? Because we've got a quadratic, 2x squared plus 5x minus 4 equals 0. We have to solve that, and we know I can't factorise it because it asks me to solve it to one decimal place. The other clue is we're in the calculator paper. So if you've got a quadratic to solve, you check the start of the exam paper, and it says x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So a, b and c are the numbers in front of x squared, x and then the last number. So taking a note of them, a is 2 because it's 2x squared, b is 5 because it's 5x, and c is negative 4. So just being careful to substitute properly in. X equals minus 5 plus or minus the square root of 5 squared minus 4 times 2 times minus 4 all over 2a, 2 times 2. You've got a mark there if you can get that substitution done. You then get a second mark for your discriminant, which is this part, and then your final answers. So the next part is to work out the bit underneath my square root sign, plus or minus. So there's my calculator. 5 squared minus, let's just do 4 times 2 times minus 4, that's 57. All over 2 times 2, that's 4. Make sure that's a big, long line there. So x equals minus 5 plus root 57 over 4, that's one answer, or x equals minus 5 minus root 57 over 4, that's going to be your second answer. So using a calculator, we've got brackets minus 5 plus root 57 divided by 4, that is 0.637, or the second answer, minus 5 minus root 57 divided by 4, x equals minus 3.137. Make sure you write in your unrounded answers first, so you don't lose a mark for rounding if you round badly. So we write down now our rounded answer, which was 1 decimal place, so we've got 0.6, one answer, or x equals minus 3.1 is our second answer, and we're done there. 4,830 tickets for the show. This is 15% more than last year. How many tickets did they sell? So this is a reverse percentage question. You need to realise that 4,830 tickets represents, well, 15% more than last year. So if last year was 100%, this year is 115%. So the easiest way then to get 100%, which is how much was sold last year, is divide by 115 and times by 100. So 4,830 divided by 115 times 100. And this is a calculator paper, so we just get our calculator. 4,830 divided by 115 times 100, we get 4,200. And we're done there. A volume question, SQA National 5 Maths 2017, Paper 2, Question 6. It says a spherical sweet is made coating caramel sphere evenly with chocolate. A cross-section of sweet is shown. The diameter of the sweet is 22 millimeters and the thickness of the coating is 3 millimeters. Calculate the volume of the coating. So the volume of the coating is not a full shape, so it's a takeaway again. So I need to do the volume of the big sphere minus the volume of the small sphere, and that will give me what's left in between. So it's a takeaway. So let's do our big sphere first. The volume of a big sphere, remember from the start of the exam paper, 4/3 pi r cubed. 4/3 times pi, and the radius, well, we need to do a bit of maths here, I suppose. If I draw a dot out here and go to here, well, that's half of 24, which is 12. So it's 12 cubed. And that gives us 7238.229. 7238.229 centimeters, millimeters cubed in this case. Now the volume of our small sphere is 4/3 times pi, and the radius of a small sphere, well, let's do a bit of maths up here. So I need to go from the middle to here. Now we already know that this bit is 24, but the coating is 3. So if I take away 6, 3 from either side, 24 minus 6 is equal to 18. 18 divided by 2 for the radius is equal to 9. We get 9. So it's 4/3 times pi times 9 cubed. In a calculator, we get 3053.628. So that means the volume of our coating is equal to 7238.229 minus 3053.628. That gives an answer of 4184.601. which when rounded to three significant figures, I think, in this question, well, that means I need to go 1, 2, 3 and round here, so it's 4180. 4180 millimetres cubed for our final mark. SQA National 5 Maths 2017 Paper 2 Question 7 had this one, and it says triangles A and B are shown and are put together to form a big triangle. Is it a right angle triangle? Well, we're going to have to identify our three sides first of all. So looking here, that's 8 centimetres there. 8 centimetres. And on the other side, we have got this one, which is a part of the big B, 19 centimetres. And then on the bottom, we're joined together, so it's 16 and 6 to make 22 centimetres. So keeping it all separate, our left-hand side and our right-hand side, we've got 8 squared plus 19 squared, or we've got 22 squared. Working both of them out separately, 8 squared plus 19 squared is 425, and 22 squared is 484. A mark for getting 18 squared, 19 squared, and 22 squared, a mark for working both of them out, and then for saying something. So the something is 8 squared plus 19 squared does not equal 22 squared, therefore not a right angled triangle. You could write by the converse of Pythagoras, but there's no real reason to mention it, but you could say that.
SQA National 5 Maths 2017 Paper 2 Question 8 on vectors. In the diagram below, RQ and PQ represent the vectors C and D respectively. Express P to R in terms of C and D. So we need to go from P to R. So we can take any route we want as long as we start at P and end at R. So we just use vectors we know. We go along D, and then we go down here, which is minus C because it's in the opposite direction. So it's D take away C. Simple as that. D take away C. And we're done there. The line QP is extended to T. TP equals PQ. V is the midpoint of P and R. Express T to V in terms of C and D. Okay, so we've got to go from T to V. So how are we going to get there? Well, we're going to go from T to P first, and then we're going to go from P to V. It says that T to V is equal to P to Q. So if it's equal and it's in the same direction, it is exactly the same vector. So I can immediately put on here that is D. And we know that P to R is D minus C. So that means that this bit here, P to V, which I'll write here, is equal to 1/2 of D minus C, because it's halfway along P to R. So now we know we're just going to go along D and then plus 1/2 D minus C. So I'm just going to write that. T to V equals D plus 1/2 of D minus C. And I can expand the brackets and simplify. So that equals D plus 1/2 D minus 1/2 C. D plus 1/2 D is 3/2 of D minus 1/2 of C. And we're done there. SQA National 5 Maths 2017 Paper 2 Question 9 on simplifying algebraic fractions. Part A, factorise 4x squared minus 25. So for part A, there's no common factor, but there is a difference of two squares because I've got a square, 4, and then x squared, and then a number taken away, which is square number, 5 5s is 25. So to factorise that, it's just double brackets. And you square root the first term, 2x, and you square root the last one, that's 5. And a plus in one bracket and a minus in the other. Part B, hence simplify 4x squared minus 25 over 2x squared minus x minus 10. So I'm going to have to factorise the bottom as well. So let's start doing that. So for 2x squared minus x minus 10, the easiest way to factorise that is to times the 2 and the 10 together to get 20. Well, it's minus 20. And the middle term I'm looking for is minus 1, minus x. So I'm looking for two numbers at times to make minus 20, but add to make minus 1. So writing down the fractions of 20, well, I've got 1 and 20. I've got 2 times 10 is 20. And I've got 4 times 5 is 20. Clearly, 1 and 20 will never add or take away to make 1. 2 and 10 will never add or take away to make 1. But 4 and 5 will. And I'm trying to make minus 1, so I'll just write down what sum makes minus 1 with 4 and 5. It would be minus 5 plus 4, and just a quick check, minus 5 times 4 is minus 20. So I can now just split this up into 2x squared minus 5x plus 4x minus 10. And you now just factorise each pair. So x is a common factor here. So I get 2x minus 5. And then on the right hand side, I just make sure that my bracket is also 2x minus 5 for the factorising. So working backwards from there, I need to times 2 by 2 to get 4, and it's plus 2. So I write plus 2. So this thing factorised is just the bracket 2x minus 5, and then inside the other bracket is the things outside the bracket, x plus 2. So now I can simplify my algebraic fraction, because I've got 4x squared minus 25 all over 2x squared minus x minus 10. Well, I've already factorised the top. Remember, that was 2x plus 5 and 2x minus 5. And I've now factorised the bottom. That's 2x minus 5, which I'll just write on this side so you can really see it, and it's x plus 2. The order of the brackets does not matter. Now you should be able to see you've got a bracket which is the same top and bottom. That's quite common when you're simplifying algebraic fractions. So I just cancel out the ones that are the same, and that leaves me with just 2x plus 5 on the top and x plus 2 on the bottom. And you can't do anything else because there's nothing else to cancel, so we're done.
2017, paper 2, question 10. In the diagram below, D, E and F represent the positions of Dunbridge, Aylesford and Fairtown respectively. It tells us that Dunbridge is 15 kilometres east of Aylesford, and it's drawn it in for us. From Dunbridge, the bearing of Fairtown is 126, which is drawn not to here, all the way round, north, down to Fairtown. From Aylesford, the bearing of Fairtown is 230. From Aylesford, 230 to Fairtown. Calculate the distance between Dunbridge and Fairtown. Calculate this distance. Let's just mark that up there with an X. No other information given. So again, the strategy is the same as before. We're trying to find angles inside the triangle, so we can use the sine rule or the cosine rule. Let's just start on this bit here. You've got north and east. That's clearly a right angle, so I can write 90 degrees. And then angles around a point add up to 360. So I can do 230 plus 90, which is 320. Give me 360 minus 320, which is 40 degrees. I can put 40 degrees inside this triangle there. On the other side, since it goes northeast, this bit also right here is 90 degrees. So that means these two add up to 126. So doing 126 minus 90, I get 36 degrees. So I've now got a second angle inside the triangle. Once I've got two angles inside the triangle, I may as well just find the third one, because chances are I'm going to have to use it. 36 plus 40, so let's just write that. 36 plus 40 is 76 degrees. 180 minus 76, because angles in a triangle add up to 180, gives us 104 degrees. So we can write that down here. And now we can check what it's asking us. To find a missing side. We've got one other missing side. So it's the sine rule, because for the cosine rule you would need this and this to get this. You've only got one side, so it must be the sine rule. So it's x over sine 40, opposites. X over sine 40 equals, and then the other side we've got is 15, and the opposite is 104. 15 over sine 104. A nice way to do this in your exam is to maybe get a different colour and just draw a line. These go together and these go together. Obviously they would go together as well, the other two, but I can't use them because I don't need that. So marks so far. You're getting a mark for 40 and 104 degrees. If you've managed to so far just calculate your angles inside your triangle, over here you've got a mark, and then you've got a mark for writing down the correct sine rule. Now we need to rearrange it. So as per usual, we can say that x sine 104 equals 15 sine 40. So x is still 15 sine 40, but then divided by the sine of 104 degrees. And that's a mark at that point as well. And then our final mark, of course, just for working that out in a calculator, 15 times sine 40, then divided by sine 104, you get an answer of 9.936. Or if you're rounding, 9.9 would be fine. And the units are still kilometres. Try not to forget your units. In National 5, there's one question where they will mark the units. They won't take marks off for forgetting the units in all questions, but there's one question you can never tell which one it's going to be, so just make sure you do your units.
SQA National 5 Maths 2017 Paper 2 Question 11. A straight line has equation 3x minus 5y minus 10 equals 0. Find the gradient of this line. So to find the gradient of a line, we're either using the gradient formula if we've got points, but we've not got points, or we're rearranging in the form y equals mx plus c. mx plus c. So we need to make it look like this because then m is the number, the gradient, which is the number in front of x, when it's in this form. So let's start off with our equation. 3x minus 5y minus 10 equals 0. So moving everything over to the right-hand side, it hasn't got a y in it, so leaving the minus 5y alone, that gives me minus 3x, because it's positive on this side, and then plus 10, because negative becomes positive when you move it over. Now we need to divide by minus 5. So dividing by minus 5, we'll get minus 3 over minus 5x, plus 10 over minus 5. Simplifying that, minus divided by minus is a plus, so I'll just leave that as 3/5 of x. And 10 divided by minus 5 is minus 2. So I now know that my gradient to answer the question equals simply 3/5, and we're done there. Laws of indices. SQA National 5 Maths 2017 Paper 2 Question 12. Express 1 over the cube root of x in the form x to the power of n. So we've got 1 over the cube root of x. You need to know from your laws of indices that a cube root can be written as x to the power of a fraction. The fraction is 1 over 3, 3 from the cube root, and because x has got like an imaginary 1 here. Once we've done that, your second law is if you've got a fraction, you can make the fraction disappear, take that up to the top, and that becomes a negative power. So in other words, we get x to the minus 1/3 for our final answer.
SQA National 5 Maths 2017 Paper 2 Question 13 had this diagram. Two identical shapes are used to form a logo. Each part is a part of a circle, and the centres are shown. The radius of each circle is 14. The logo has half-turn symmetry about a midpoint, so now it's just saying you can turn it. And AB is 48. Calculate the height of the logo. Okay, this looks a little bit harder than it is. We just need to get a right angle triangle out of this. So let's just pick one of these circles. If I drew a line to here and then made the radius, that gives me a right angle. Now, do I know the radius? Yes, it's 14. Do I know anything else? Well, I know the whole length of this is 48. So from here to here must be 24. So from here to here, halving that again, must be 12. And now I can call that x and get my distance. Now once I've got that one, it's going to be the same on here. So then it's just adding in a radius and a radius. So I can just work from there. So x squared is 14 squared minus 12 squared. We've got 2 marks so far, one for the right angle triangle and one for the answer. So then x is the square root of the answer to 14 squared minus 12 squared, which is 7.2. And therefore height, well, we'll just do it in stages. We have got a radius plus the answer x, and then we've got that again, so double that. So we can just write down the radius, remember, was 14. 14 plus 7.2, and then times by 2, or just add 14 plus 7.2 again. And you get an answer of 42.4 centimetres. SQA National 5 Maths 2017, Paper 2, Question 14 on arc length. The diagram shows part of a circle, centre O. It says the radius is 6.4, the length of the major arc is 31.5. Calculate the size of the reflex angle AOB, in other words, this angle here. So we're just using arc length again and working backwards. So we'll just write down everything we've got. So arc length, I'll just write AL equals angle over 360 times pi times diameter. We've got the arc length, that's 31.5 on the left. We've not got the angle, so I'll just write theta or x or anything you want, over 360 times pi times, now be careful, the diameter is not 6.4, that's the radius, so I double that to get the diameter of 12.8. Now if you can get that far, you get a mark. Angle over 360 times pi times 12.8. And then we need to work backwards. So again, remember, we start with this. So our angle equals 31.5. And I'm going to divide by everything on the top, pi times 12.8. And we're going to times by everything on the bottom, 360. Then we get a mark if we can get that far. And then for a mark for our final answer for calculating our angle theta, when we do 31.5 times 360 divided by brackets pi times 12.8 is 282.003, or to a reasonable degree of accuracy 282 degrees for our final answer. SQA National 5 Maths 2018, Paper 2, Question 2 on arc length. The diagram below shows the sector of a circle, centre C. It shows the radius is 7.4, the angle is 320, and it asks us to calculate the length of the arc. So this is a straightforward one. We can just write down arc length equals angle over 360 times pi times diameter. Always write down your formula first. Your angle is 320. We've got that over 360. And we're timesing by pi. And our diameter, well, it's told us 7.4. So we need to double that, so that is 14.8. Get a mark for writing down our formula. We get a mark for getting our angle, 320 over 360, our fraction, 320 over 360. We get a mark for our final answer, which worked out at 41.32 centimetres. And we're done there. A wind turbine has 3 blades as shown. And it gives you this equation for the tip of the blade, and it says calculate the height of the tip of the blade when it's turned for an angle of 60. So I have to substitute 60 in. So for part A, I can just write H equals 40 plus 23 cos 60. That's 40 plus, now the cos is 60, use your calculator as 0.5. So you would get 0.5 times 23. Which is 11.5. So you get a final answer of 51.5 metres. Part B says the minimum height of the tip of the blade A above the ground. Now this is a little bit tricky to think about, but we've got the equation here. 40 plus 23 cos x. Now if you think of a cos graph or anything else, you'll realise that the minimum the cos goes down to is -1. So it's really just asking you to realise that, and you've got h would then be 40 plus 23 times -1, so minus 23, which is equal to 17 metres. Now if you're going to do part A and part B, don't worry, we only have one mark. Part C is the meat and potatoes of this. Calculate the values of x for which the tip of the blade is 61 metres above the ground. So for part C, h is equal to 61. So I can write 40 plus 23 cos x equals 61 and solve that equation. So taking away 40 for both sides, 23 cos x equals 21. So cos x is 21 over 23. So then we can work out x. X is the inverse cos of 21 over 23. Which is 24.1 degrees. But that's not the only answer, remember, because if we draw a cast diagram, we've got A and C, which is 360 minus, so we could have x is also equal to 360 minus 24.1, which is 335.9 degrees.